Hello, Professor. Thanks so much for meeting with us today and taking the time to do that. We're really excited to have you here to talk to us. To start, do you want to take like a minute or so to introduce yourself?
Oh yeah, sure. Yeah. Well, first of all, thanks for inviting me. And I think this is a great initiative. I watched some of the videos and they're so great. So thank you for organizing this. My name is Angjoo Kanazawa and I'm a assistant professor at UC Berkeley in the EECS department. And my research is in the intersection of computer vision, graphics, and learning, especially in 3D. Yeah.
Awesome, thank you. Yeah, so you started off your recent workshop talk at ECCV by saying that 3D is really cool. So why do you find 3D cool as a field to do research in?
Yeah, I think, 3D, first of all, 3D is really cool because there's a lot of cool and fun applications that you can do once you can perceive 3D from images. So for example, in my work, I reconstruct things like cats and birds, and we can like 3D print this, and that's really fun. And it's like really nice to have something physical. Of course, there's a lot of things like, markerless motion capture that you can do from your video, and then you can like manipulate your own avatar. And like you can have like AR or mixed reality systems that can interact in the 3D world like you would, like as if it's actually there. But I think all of these things are true because we live in a three-dimensional world that is dynamic. And so when we recover things that are actually in the space that we reside in, there's a lot of cool applications also in terms of like creativity. Like artists can make a lot of things. So more recently we have this work called Paifu that can reconstruct people from images, and the students did a really good job of making a very nice collab. And so we put this around, and everybody on Twitter, if you search Paifu, are reconstructing themselves and animating themselves, and it's like really fun. But there's also really like other, just not just fun things, but a lot of like impactful things you could do. Like if we can recover 3D human motion a little bit more precisely in future, then we can do better like biometric analysis from your phone, or all of these really nice things, or going into robotics and actually interacting with people. So yeah, so there's a lot of cool applications. So this is why I'm excited about it.
Yeah, it does sound super cool. You're making me want to switch fields. Yeah, you've done a lot of fascinating work with morphable models. So I was wondering if you could talk a little bit about what those are and why they're useful in computer vision, and also if they have any key limitations.
Yeah. So morphable models, I think just in generally in this conversation, or more generally, like deformable models are just a tool to represent objects that can move around or not non-rigidly deform, like non-rigid objects. Okay, and then like this is a useful tool because traditionally 3D has been a really, a fundamental thing in vision, and lots of people have been studying it. But most of the approaches follow geometry, and all of these approaches are only available for rigid objects. So if it's rigid, there's a lot of geometric methods that we can do. But if in the video there's people or cats that move around, these geometries no longer hold because they expect things to be rigid. So morphable models are like one way of dealing with these, moving objects. And like, one nice thing about them is that you basically have like a model that can basically move around, morph into one shape to another, which means you actually preserve like correspondences between different shapes or poses, and so this, like, maintaining correspondences can be a very useful thing in vision. I think one shortcomings as of now, I think, is that like the limitation is that these tend to be category specific, because it makes sense. It kind of describes how one category of objects morphs from one to another. And so, if you wanted to make it category agnostic, I think there will be new approaches to do that. Yeah, and it's also not just for cats or birds or humans, but it's also like category as a whole. Like even though every single object of, say, car is a rigid object, if you look at many different cars, they have different shapes, and you might be able to explain all of them through a single morphable model. And so that's like another use case also.
Yeah, that's super cool. You have some really interesting recent work on learning without key points. So I was wondering if you could talk a little bit about that.
Yeah, so a lot of the challenge in 3D is that unlike 2D vision, where it's easy to say like, have people annotate where the key points are, or like segmentation masks, with 3D, it's really difficult to like have the labels from humans. And you can certainly obtain this. You can put them in like a motion capture studio, or like capture them in this like multi-view rig. But then, the more you do this, the more expensive it is, and also not very ecological way of like learning about the world. When babies don't really have a 3D CAD model that gets inserted to their brain and learn about the shapes. So, you want to develop some ways that's more natural. And that's like one of the biggest challenges and like new goals in this area. And so so mainly that line of work is really talking about how can we learn something about the 3D world when all we get is 2D observations without any explicit 3D supervision. So in the beginning, we were using these things like key points to kind of help us. In the more recent work, we got rid of this, and like an intuition, I'm not so sure how like technical I should get into this, but the intuition I think is that key points specifically, for example, say like left eyes, you can have every single left eye of the bird in the image labeled, and this really gives you correspondences. Like every single image, where the left eye is. And this correspondence in turn also gives you this information of which direction are you looking at this bird from. And this kind of information is really important for doing 3D reconstruction, the viewpoint. And so in the more recent work, we developed an approach that can replace this by coming up with a new optimization algorithm that can do this viewpoint search without actually having the key points. But I think the thing to really think about is, how can we learn about 3D without having 3D supervision? And that's really like the direction that we're trying to pursue.
Yeah, I think that's a really important question to be answered, since, there's an abundance of 2D data, but not 3D data. Awesome. So what are some of the big outstanding challenges besides learning without key points that you face in 3D vision?
Yeah. I think it's really similar in a sense that like there's a lot of challenges, but one of which is like really data. You don't really have lots of data with ground truth 3D like I just talked about. And like maybe you don't need this perfect scan, but if you had multiple views of the object, so from a single image, 3D is really hard because the reason why 3D is interesting to me fundamentally is that we live in a three-dimensional world, and that's what the world is. But everything that gets passed through our eyes is only like a 2D projection of the world, but we can still really understand what's behind it. And if you only have one view, it's very ambiguous because there could be multiple 3D like interpretation of the world that will give you the exact same 2D projection because you're losing an axis, but by observing from multiple viewpoints, you can really restrict it. Like, this is why when you don't really know things, humans really move around. And we do have two eyes, but they're close together, so you don't really get that much information. You get some depth, but like to really understand what's behind, you kind of look around in it. So if you had lots of data where you get to look around, so like video or multiple views, this can also give you 3D information. So that's like if you don't have 3D ground truth, you can have this like multiple views. But it's just even then the video data is so difficult to obtain. So like if you think about ImageNet, you get some images of car from the internet, and like that's a lot easier to obtain than if you actually had to get like a video of a car that's like kind of similarly videoed, to your like view. Like it's like real world videos are going to be really cluttered and like noisy and lots of things going on. You're not going to have like a person who take a picture of like a car around and like have like thousands and thousands of those. And so like I think real challenge is like where is the data coming from, and how can we learn from this kind of noisy data? I think is a real challenge. So that's one thing. I think another thing is also like representation, like what is the right 3D representation to explain what's going on is, we still don't really know. There's many representations and there's a lot of pros and cons for each of them. And, I think it also depends on your applications. Like if you wanted to use something for robotics, the kind of 3D representation that you would ask is very different if you really wanted to just get a really nice reconstruction to use for your movies or something like this. And so figuring out this like right set of representation that can be used for many tasks, I think is another real challenge. I think those two things, to begin with.
That's so cool. I guess I never thought about the need for a video net kind of like the analog to ImageNet. Does anything like that exist in the field?
Yeah, there is a couple of really cool initiatives. So one thing that pops into my mind is that of Epic Kitchen, and this is an eco-centric video. So people wear like a GoPro, and then they collected a large data set of people making things in the kitchen. And I think this type of data is really cool because it also has how humans really interact with the environment, but it's also super hard. And I think another really hard thing about video is that, like, you know, you tend to think of an object you want to reconstruct, like a cat, you know, but then like in real life, in videos, like you look away and then you look at this object away, and like 2D videos are really only like a snapshots of the real world, you know, and you really want to recover the underlying thing and you only get sparse views of it. So putting this together is really hard. And these in the wild is like a jargon for saying like not controlled, like taken by you or your friends that's on internet. Those are really a lot more variants. It's like lots of things going on. And so dealing with that kind of data is really hard. So yeah, so that's another thing, is that if you really collected nice quality data, like multiple views or put people in studios, then it starts to get more and more controlled. So the challenge is the more high quality the ground truth 3D or the data is, the more controlled it is, that it's not going to really generalize to the real world. And so you really want to be trying to do this from like real world images or video streams. And I think that's really another challenge.
Yeah, that sounds really hard to balance the, you know, panoramic 3D in the wild and also controlled but not too controlled. So wow, yes, that's a big challenge. I have a question. What excites you most about your field going forward?
Yeah, so there's a lot of so of course there's lots of excitement in deep learning, and then there was a lot of approaches in 2D vision, and more recently in the last 3 years I think a lot of people are moving to 3D, which is really exciting because now there's like a lot of papers in this field, and it can be a little bit overwhelming, but also like the progress that we see is really cool. And like there's a lot of things that I see, like even in my 3D human reconstruction things, like results that I wouldn't have expected like few years ago. And also like more recent things like NERF, I'm not so sure you've heard of, but it captures really nice 3D reconstructions of the world. And so there's really cool things. And I think moving forward, I think there's two directions that I'm excited in. And like one is 3D for reasoning and image understanding, or robotics. And so for these things, you don't really need, you want to obtain like a high level representation of what's going on. So maybe like my joint kinematics, or like my order, like where am I, you know, which direction am I looking at, you know, where's the objects, and like in 3D space. And these things are useful for like understanding what's happening in a video, or using it for robotics purposes so that like robots can learn from people. And then so that's really exciting too, because there's a lot of exciting work in robotics too. And the other direction really is capturing the world as is. And I think that's why it's really cool, because we live in a three-dimensional world where people move around, right? And so right now we have photographs, but I think in the future we're going to have this kind of like 3D video memory kind of thing. And so the kind of crazy the idea that I push to my students is this idea called the Pensieve project. And so Pensieve is this thing in Harry Potter where you can drop like this your memory, and then you can go in, right? And then once you go into your memory, you can like float around it. And I think that's really cool. And like it would be nice if you can like, you know, I think there will be a nice capture system where you can actually capture your stories or your memories in this format. And there's a really cool, exciting article from New York Times that is using 3D photogrammetry to tell like new kind of journalistic stories, because you get to really explain, you know, they capture like this, I think the scene like after hurricane like scene in Bahamas, I believe, and then you really get to experience it. And so there's, I think, a lot of like cool stories that you can tell once you recover 3D. So yeah, I think, you know, I think it's more like pre-3D and then like useful 3D in both directions. There's so many new cool work. So I'm really excited about both of these directions.
Yeah, I love the Harry Potter reference. Switching gears a little bit, I'd love to hear about your experiences as a research scientist at Google. So how has your experience been different from the research that you conduct within academia?
Yeah, so thankfully at Google, I'm still in research role. So I'm really basically just doing research. But the nice thing about being in industry really is compute. So you get to really approach problems in a way you can't in academia. So, we crunched a lot of videos, there's YouTube and like lots of compute. And so that allows you to kind of ask questions that you can't usually do in academia. And so I think that's definitely a positive. Another thing though is that being in industry also really tells you what kind of problems are interesting or important to solve, and like privacy is a very big issue right now, especially in machine learning with all the ethical concerns. And so, how do you deal with using data for machine learning models? These are new things that I really learned a lot about and did a lot of back and forth with lawyers. So those are like new insights that I also have. And but like one thing that I really, really noticed once I started to be in industry is like this, the gender inequality, or like the lack of diversity in any metric. So, and it's interesting because like as women in computer science, I think we're all kind of used to this situation, right? And like, of course, I always thought it was a problem, and I always tried to like engage in diversity, related things. But I think in a university setting, you have your peers, and you're like, maybe there's not that many of you. But once you go to industry research, I realized that, because as you go up and up, there's like more and more less diversity. It's just that you see how it's not just your peers, it's just this entire like whole line of people, and like how diversity is a seriously critical issue right now. I think that awareness was something that I didn't really have, and I don't think it's just a problem at Google. I think it's just that just industry in general, just higher level, I mean, also at faculty level, I think it's very different. And so that kind of awareness, I think, is something I didn't really have before. So yeah, so those are things that hopefully we can start to change. Yeah, and so that's kind of about industry. Yeah.
Yeah, thanks for talking about your experience with that. I think it's definitely a unique perspective, and diversity is obviously an issue in academia and industry, but it's really interesting to see the differences between the two when it comes to that. Could you talk a little bit about your trajectory? So how you got into machine learning in your field?
Yeah, it's interesting. Like originally I wanted to be a software engineer because I really like to make things. I was like, why would anybody go to another extra school for 5 years? And I just like didn't really know what it meant to do a PhD. I didn't know that it was funded. It's funded. If you do any kind of STEM type PhD, the entire time you will be paid, even though it's not that much, and your tuition is also paid for. This is something I didn't really know. I wasn't like in like that excited. I didn't know what research was. But when I was in my third year and fourth year, I took a computer vision class by Rob Fergus at NYU. That's where I went to school. And then he really inspired me to do this kind of vision type machine learning research. Yeah, actually back in the day, this is before pre-learning of deep learning, right? And so back in the day, if you're doing computer science, like the thing in the department to do good well was to get into Google or go to Goldman Sachs. So, and so actually I had an opportunity to do research with Rob in like the first summer I worked with him. But then I already had this like Goldman Sachs like internship, and I was like, I'm gonna go do this thing. And so I actually ended up not doing research with Rob, and I went to do this internship, and like the internship people were actually great, but I already kind of hit this kind of midlife crisis because I was kind of I wanted to do more than just software engineering. So when I came back, I was like, I really made a big mistake, and I wished I worked with you over the summer. And then Rob was actually kind enough to still work with me, and then we read lots of papers, and that was really inspiring. And that's how I decided to go to grad school.
That's really interesting. Wow, a pit stop at Goldman Sachs. I love it. For students that are interested in getting into machine learning, do you have any recommendations for if a student should begin on the theory side or the applied side, or a combination of both?
Yeah, so my research is quite applied, so of course I'm biased, but I really think fundamental understanding of linear algebra is really, really critical. And so I think it's very good to work on your fundamental math classes, and those will really give you really good geometric insight. And if you can think about it in terms of, these intuitive ideas about the math, it really helps you. And so I highly recommend you take very good math classes. in whichever direction it is. And then, but I think, I think it's really important to have something like, I want to do this. This is the thing I want to solve, like, and for me, I really like cats. And so I really wanted to reconstruct cats. And like, that seems kind of silly, but actually there was a lot of interesting questions about this. How do you actually model the 3D representation of this non-rigid objects? And that really became my thesis. And so I think it's really important to keep some application in mind. I really want to do this because that way you also get to get your hands dirty, but while at the same time taking really good like fundamental courses. And I think those would be, yeah, my advices, I guess.
That's great advice. Do you have any additional advice for younger students interested in the field, especially women or underrepresented students?
Yeah, so I think it's really important to remember that it is possible for you to do really good research and cool research. Like, and given opportunity, the right timing, I think anybody really can do this. And maybe you are, it doesn't really matter. Like, even if there aren't that many people who look like you in the field, you can do it. It's and we really need that kind of diverse voice. And so I really want you to kind of remember that. If you're intimidated by the math, I think it's okay. Like, they're not as intimidating as it looks like, and they're just tools for you to think about, and you'll be friends with them. And so I think that's the most important thing I think I would say. And let's see. I think another thing is like, it's really important that you be yourself and like don't be afraid to ask questions, especially that like later and later stage that you go. If you don't know about it, very high chance that a lot of people around in your same class or your reading group won't know about it also. And so you should ask a question, and don't be afraid to ask questions. And I think that's really important in moving forward. I think that's a really useful skill to make. Yeah, and I see. I think another thing is, I think it's really like important that like you imagine like what kind of future you want to live in, and then identify the problems you want to solve. And moving forward, I think technology and artificial intelligence, I don't really like to say that, but like, machine learning is going to be a really important aspect in every sector of life. And so you can have a lot of big impact. And this is why it's really important that we hear from lots of diverse voices. I know that there's a lot of like concerning applications in computer vision, like surveillance or, fake news or, all of these things. There is a lot of bad ways you can use technology, but there's also good ways you can use it. And I think we need young people to know that you don't just have to operate in the way current problems are defined. You can define new problems. You can work it and you can use it to make it used for environment or all these like more positive applications. And so know that you can make up your own problems, and that's probably better than just solving somebody's existing problems. And so my advice is to really think about what kind of future you want to live in and what kind of problem that you want to solve, and apply these learning techniques in that direction. Okay.
Awesome. Yeah, thank you. That was really inspiring advice. And thank you again for your time and taking the time to chat with us today.
Okay. Well, thank you so much. I enjoyed chatting with you. Hopefully this was helpful.